So in this problem of motion of several particles, we have two rockets, and two rockets are fired at a fireworks display. A is launched at 100 meters per second, and B is launched at a time t0 seconds later with the same initial velocity. The two rockets are timed to explode at 300 meters when A is falling and B is rising. So find the time difference, t0, when the rockets are launched, and find the velocity of B relative to the velocity of A at the time of the explosion. So first thing, if we put in what we know that A is launched at 100 meters per second, and some time later B is launched, and it's launched at 100 meters per second. A is going to go up to a high point and then fall back down due to gravity, which is constant acceleration. So gravity is acting against our positive velocity. So gravity is going to be equal to negative 9.81 meters per second squared. And this makes sense. What else do we know? We know that this distance right here, when the two fireworks meet, is 300 meters from the ground. So this final distance is 300 meters, and our initial distance is 0 meters. So we're going to reference everything from the ground, and this is our positive direction. And if we write down everything we know for firework A, we have an initial x of 0 meters, a final x of 300 meters, we have an initial velocity, which is equal to 100 meters per second. Its units are important. And we have a final velocity of unknown. We have an acceleration, which is due to gravity, of minus 9.81 meters per second squared. And we have a time of unknown. We don't know how long it takes this firework to come up and go to 300 meters. So if we look at our kinematic equations, which we can use because of gravity, and gravity's constant acceleration, so we have v equals v naught plus at, x equals x naught plus v naught t plus 1/2 at squared, and v squared is equal to v naught squared plus 2a times the final position minus an initial position. And we want to look at these three equations and figure out which one we are going to use. So we don't know a time, so if we want to solve for time to figure it out, this equation has a time in it, and this does. However, we also don't know our final velocity, and this requires a final velocity, so this is not a good equation to use for right now. And so if we plug in what we know to this second equation right here, we have a final distance, which is 300, is equal to an initial distance of 0, plus your initial velocity, which is 100 meters per second, times some time. We don't know it. We're going to solve for it, plus 1/2 times the acceleration, which is minus 9.81 meters per second squared, times the time squared. And if we solve this equation for time, we should get two roots. It's it's a quadratic, so we should get two roots. And we do. We get time is equal to 3.65 seconds, and time is equal to 16.7 seconds. Well, this is strange because normally when we solve a quadratic like we've been doing and we get a time, we get a negative value that we throw away, and the time that we're looking for is the positive value. But right here we have two positive values. But it makes sense if you think about what's happening in this equation, in this problem. We have a velocity of A that's being shot up, and at some point when it's going up, it reaches 300 meters, right? So it has to go past 300, it has to go to 300 meters in order to go past 300 meters. And that's this first time. It takes 3.65 seconds for A to go up to 300 meters. Now, when A continues to go up, it goes to some high point and then starts to fall down. And when it reaches 300 meters again, when it comes back a second time, this is this second time we have 16.7 seconds. So it makes sense. It makes sense we have two positive roots. But the question's asking to find the difference when, find the time difference of the rockets being launched. So we know it's going to take A 16.7 seconds to come to 300 meters. And we also know that from the ground, because B is being launched with the same initial velocity, it takes 3.65 seconds for B to get up to 300 meters. So when should we launch rocket B so it meets rocket A at 300 meters? Well, if we shoot this second firework when it's 16.7 seconds minus the time it takes to get up to 300 meters, which is 3.65 seconds, we should get our answer. And when we do this, we get time is equal to 13.05 seconds. And if you're not really following, this is what's happening. At time 0, our first rocket is right here. Time is equal to 0. And it shoots up. At time is equal to 3.65, our rocket has reached 300 feet in the air and going in the upward direction. It continues to go up, and we still have not shot this second firework. So it continues to go up, finally reaches a top at some time, and starts to fall back down. At 13.05 seconds, after it has initially been launched, we need to shoot our second firework right here. So it gets launched at 13.05 seconds. So after 3.65 seconds, our second firework is 300 feet in the air. And our first firework continues to fall down, and 3.65 seconds after this 13.05 seconds, it's also at 300 feet in the air. And then they both explode, and it does what it wants. It was designed to do. So the second part of the question, this is the first part right here. The second part of the question asks us to find the velocity of B relative to A at the time of the explosion. So the velocity of, let's look at the velocity of B first. The velocity of B is the second firework. So we know it has an initial velocity of 100 meters per second, and it has an acceleration of 9.81 meters per second squared, and the time it's in the air is 3.65 seconds. So if we do this out, we get a velocity of B is 65.1. Velocity of B is 64.19 meters per second. It's positive, so it means that it's going in the upward direction. Now, when we look at our velocity of A, and I should mention I'm using this kinematic equation right here. We know everything on this side of the equation, so we're just solving for our final velocity. Now, the velocity of A is equal to the same initial velocity. It's shot at 100 meters per second, and the acceleration of it is only gravity is acting against it, so it's negative 9.81 meters per second squared, and the time that it's in the air is this entire time, which is 16.7 seconds. So if we perform this calculation, we get the velocity of A is minus 63.8 meters per second. And notice this negative sign right here. This means that the velocity is moving downward, which is what we think it should be doing. So that makes sense. So this is actually moving downward at 63.8 meters per second. And question's not done. The question's asking, find the velocity of B relative to A. So the velocity of B, which is relative to A, is equal to the velocity of B minus the velocity of A, which is equal to 64.19 minus a negative 63.8. And when we simplify this and add these two numbers together, we get 127.99 meters per second. And since this is a positive 127, it's going in the upward direction.